All right, a rod extending between x being 0 and 14 centimeters has a uniform cross area of 9 centimeters square. It is made from a continuously changing alloy of metals so that along its length, its density changes steadily from 27 grams per centimeter cubic to 19.3 grams per centimeter cubic. So we're going to do part A, identifying the constants B and C required for the expression for this. So this is going to be the density formula that they're given, B plus Cx. So let me rewrite that. So B plus Cx. And to describe the variable density, all right, so in other words, folks, this is the density. And it's saying that this is going to be a rod with a cross-sectional area, not that it matters, but its density changes from 2.70 grams per centimeter cubic to 19.3 grams per centimeter cubic. So when x is 0, I guess that's the cross-sectional area. This would be square if that was the case, but whatever, let's not overly think this. Anyways, I encourage you guys to pause this video, and you guys can. All right, so presuming you pause this video and give this problem a shot. I know I haven't really. Just press the record button right straight after. Describe the variable density. All right, so folks, identify the constants B and C. So let's find what those constants is. And remember, folks, initially the mass, which we're going to be finding, is going to be the formula of the density times some volume, and we're going to add them up. But that density is going to be some area square, some centimeter square times some distance square. So I'm going to start this as writing P A dx. Once we identify what those constants are, so we're going to change the formula a bit, but let's start with identifying what those constants are. So initially, from 2.7 grams per centimeter cubic is when x equals 0 meters or 0 centimeter, or I think it's 0 centimeters. I don't know what the unit is. I'm just going to put 0. So in other words, if the density is 2.7 grams per centimeter cubic when x is 0, right off the bat, that's your constant B. And there we go. So now we identify what B is. So when the length is, what is it, from 14 centimeters, when x equals 14 centimeters, the density changes from 2.7 grams to 19.3 grams per centimeter cubic when x is 14. So this is going to be equals B plus Cx. B is 2.7 grams centimeters, so this variable is already solved. X is 14 centimeters, so all you have to do is take this value minus the B divided by x, and you get your value C. And let's get what that value is. So once you find your constant, folks, your B is going to be 2.7 grams per centimeter cubic, and your C value is going to be 1.18, or I guess I'm going to round up in this case, grams per centimeter cubic. So those are your constants. Now let's replace this with this formula. So now you have the density formula. Times dx from being from 0 centimeters to 14 centimeters. And now all we have to do is carry out the integral. So I'm not going to show you how to do this integral or whatever the heck, folks. I am just going to put this straight up in my TI-84 calculator because I'm too lazy to even do the integral. So yeah, folks, if you have your feature, I don't know where to look on this thing. Oh, there you go. Yeah, 0 to 14. I'm putting in my calculator right now. What is that? B plus Cx, C times x, times 9. And I got, once you carry out the integral, the mass is going to be 1386. What's the units? Grams? Oh yeah, of course it's grams. Okay, grams. So there we go, folks. That's all they're asking for. Pretty straightforward problem. I don't understand why some of these problems are just like blue and red. It's just all over the place in terms of difficulties. Because in my opinion, this is pretty straight fucking forward. I mean, people are not, like, are people this really that retarded that they can't figure this out? Like, I don't get that. But no offense to anybody, but seriously, folks, come on. Like, you have to at least have some decent common sense within you. All right, folks, I'm out. Anyways, folks, those are the solutions. I hope you enjoy.